Hey there, everyone, and we are live. Welcome to another Seattle Data Guy Live. Whether you're on LinkedIn or YouTube, welcome all. Also, today we have two fabulous guests, Rui and Richard. How are you guys both doing?
All good. Great to be here. Thanks, man.
Great. Yeah, good. Awesome. Well, today we're going to talk about SQL, kind of where it's going, where it's headed. You guys have both kind of have different connections to it. So I wanted to kind of give you guys a quick intro. So Rui, if you want to start, just let people know your background and kind of how you've gotten involved and et cetera.
Yeah, sure. So, hi, everyone. So, my name is Rui. I'm from Portugal, where I am right now, this small country in the Atlantic. I have 15 years of experience with data, highly passionate about this space. Throughout these 15 years, I had different roles: data engineer, data scientist. In the last 8 to 9, I had more leadership positions, but I worked in companies like Nike. I worked in companies like Facebook out of London, and right now I'm leading data engineering and architecture for the H&M Group. So besides all of this, I'm really passionate about technology. I write books, I publish articles as well. So I'm officially a data nerd, I would say. So,
That's
but
awesome.
Richard.
Yes. That's pretty. What's the title of the book you with O'Reilly? It's
Yes. Thank you. I didn't want to be the one making that promotion, but thank you for asking for this. It's a book called Analytics Engineering with SQL and DBT. So it's basically this mix between data engineering and data analysts, how it's emerging out there, and how DBT and SQL are playing a big role in this transition.
Yeah. Thanks, Rick.
Thank
Richard,
you.
I'd love to hear your background.
Well, great. Yeah, I'll be reading up your book once it's live, right? Hi everyone. I'm Richard. I'm the co-founder and CEO of Roe AI. I've been in data world for about 10 years since I was in UC Berkeley doing the research in the School of Business, and then later went to LinkedIn, which is a very data-driven company. The Kafka was invented there, so I've done a lot of near real-time data engineering. And then I went to Snowflake, leading some of the AI efforts there. So currently, I'm the co-founder and CEO of the company that's building the SQL version of unstructured data analytics platform. So very excited to be in this call, and I'd love to discuss more on that.
Yeah, no, excited to kind of hear more about both your backgrounds as we kind of go. But to kind of get kicked off with this chat on SQL, before we start going into the future, I'd love to kind of get some thoughts on the history of SQL. So, Rui, I think you had some thoughts that you want to share.
Yeah, of course. So many of you might actually not know, but SQL is a 50-year-old language. So it was invented in the 70s. So it demands a little bit of respect. It's a really old lady or man, as you prefer. But when SQL was invented, it was actually invented by two researchers of IBM, and it was fully focusing on relational databases. It was invented really to be super simple, to interact with IBM databases, but not just that, but really to have a simple interface that anyone could use to actually query data in relational databases. Of course, a lot of things have happened over time, and SQL kept evolving. Although it's an old language, it was not static. So as you guys know, in the 80s came data warehousing and so on and so forth. So SQL became this power language to build data warehouses, to model them, to implement star schemas and snowflakes. But these were the golden ages of SQL, right? It was probably the only interface that people actually had to interact with databases. But then we had a small winter. And I think this is very interesting for people to know as well, that in the 2000s, we had, the growth of big data. And when we had this, SQL had a little bit of a winter. Hadoop and MapReduce, it grew a lot. There was Scala, there was Java for data processing and so on. But I believe we all know what happened. The community brought back SQL again, and we had stuff like Spark SQL. SQL started growing a lot. And I think right now, and just to give you this summarized version, Ben, I think SQL is becoming some sort of a virus. It exists everywhere. I think in the analytics world, we really see SQL as that simple interface that's very easy to use. And without going into a lot of details, I think there is probably one feature that makes SQL so appealing, is that it's really close to the English language, but not that much. But it's a little bit more high level than the siblings, like functional programming or procedural. So it's a lot easier to actually learn and to use when interacting with systems, because you focus on what you want to get from that data storage. You don't focus on the how. You don't focus on algorithms and functions. You just give an instruction and you get the results. And I was lucky enough to see, this growth of SQL over time. I started with MySQL and SQL Server, and these days I'm using SQL in DuckDB. I'm using it on dbt. I'm using it on Google SQL to interact with LLMs directly on BigQuery. And it's really fascinating to see how SQL actually grew so fast in the last 50 years. And I think it's also thanks to this great community that keeps bringing SQL to life and making it one of the most resilient languages out there. So without really going to a lot of details, I think this is a very interesting context that maybe some people don't know, maybe some do, but it's always good to keep in memory that this is an old language that keeps evolving over time.
Yeah. I think the thing I always think of when, like, with SQL being an older language that, like you said, evolves, is joins, like just something as simple as joins that weren't, I think, really added until somewhere in like the late 90s. And then I always can tell when someone's been coding or at least working on older systems, because the way they end up joining in their queries is always in the where clause instead of with a join. Oh, go ahead.
And common table expressions and window functions. This is all stuff we use right now, but it was added over time. Yeah. So it was not there from the beginning.
Yeah, exactly. If for anyone who's ever, they might not do this anymore, but for anyone who's ever been in an interview where you're like, I'm going to use a window, function, I would always have an interviewer be like, well, can you do it without it? Because if you're on some older instance of MySQL or something, it's not going to have that window function. You've got to do it without it. So, but I think nowadays most systems do, but I still occasionally run against older systems. Cool. But, just to kind of follow that up, I'd love to kind of dig into the why, like what has made it so dominant, right? Like we've seen kind of that it has been, but like what is making it so dominant? And Richard, I'd kind of like to get your take on that.
Yeah. It's, I think to Ray's point, right? SQL is kind of a declarative language. So meaning high level declarative, anyone can just write it. And it's probably the simplest way to transform the sheer volume of data. Like if you think about without SQL, what do you do, right? Have someone run a Python script, and then have to allocate a bunch of machines, and then run it somewhere, and maybe it will break like 10 times before you can like make it running. But with SQL, and to Ray's point, the commercial data warehouse like Google BigQuery, in Redshift or Snowflake, right? Everything is kind of on cloud, so you don't worry about infrastructure. The commercial provider maintains the scalability layer for you. So in some sense, thanks to those bigger players, right, where everybody now can just write. The only thing we need to care about is write the correct SQL to transform the data. The rest of it is on the cloud. So I think that's the kind of the beauty of it with the technology and with the big data advancement we have today.
Yeah, Rui, do you have anything else in terms of you'd like to add in terms of where you like why you see SQL so dominant?
Yeah, I think probably the secret is actually in the roots of SQL. And that's why I love looking at history. I mean, if you guys ask Don Chamberlain, one of the founders of SQL, he's going to tell you that when they designed the language, they designed it for business users, not really technical people. And to do so, to build something for business people, you need to make it simple. You need to make it easy to learn. And the learning curve needs to be super, super short. And honestly, this is what we see out there. It's really easy to teach SQL. I've been teaching SQL for years, and people pick it up quite fast. It's a bunch of clauses and operators. So the rules are quite simple. And again, it's close enough to the English language to make it super simple to learn and use. And I think this is probably contributing for making SQL so dominant out there. Funny enough, it was probably massified by the technical people. That's a different story, because we are also super lazy. So we like to use simple interfaces as well. So I think, if you look at the roots, you see why. It's simple, it's easy to use, it's declarative, it's versatile. You can actually port it from platform to platform. And if you learn it once, you can use it in Snowflake, in Databricks, in SQL Server, in MySQL. There are so many platforms where you can actually use your knowledge around SQL that makes it super appealing. And I think it will keep coming back because it's really massified out there. So again, it's more of a theoretical concept, but I think the simplicity is one of the key factors there.
Yeah, no, I think there's definitely that. I think the push for more people to be able to access data over the last, decade or so has also like just added to it. I do think like sometimes you especially from the technical community, because it is so simple, there's a little bit of shade that's sometimes thrown towards it, because it's like, well, it's not a programming language per se, or it's not, there's a little bit of shade, but like it's, again, I think it's hard to kind of deny and its effectiveness. Or maybe not more than anything, it's stickiness. Because like you said, it just keeps coming back to SQL. In terms of like, before we dive too much into kind of where things are going, if people are out there trying to learn SQL, do either of you have any tips? And I'll kind of put that out for either of you to answer.
Well, subscribe to Ben's channel. Ben shares a lot of tips. Yeah, but these days ChatGPT goes a long way. I think this kind of there are so many well, previously without ChatGPT you would go to Stack Overflow and ask questions, or some Reddit channels. But now it's probably the best. You passing the schema, and it will just pass you a business query. A lot of companies are building text-to-SQL bot today. So I now see like although it's still early days, right? They can make mistakes, but yeah, the AI can definitely teach how to use the SQL and how to optimize it better than a lot of sources in the past.
Yeah. Go ahead. I'm sorry.
I was going to say that it's an amazing answer, Richard, and I'm quite glad you brought ChatGPT to the equation, because normally these days when we teach SQL, we actually use ChatGPT to generate most of the exercises and the database models and so on, because SQL has 50 years. There's so much content out there that I don't think there are a lot of excuses not to be able to use ChatGPT or just Google to actually learn a little bit about SQL. And then I think there's also another dimension. There are all these new, well, quite old now, but strong players in the market, like Snowflake, like Databricks, like Google with BigQuery. It's a huge SQL powerhouse. All of these allow you to create free accounts. So you can actually just create an account. And honestly, Ben, going straight to your question, I think the best way to learn SQL is to apply it. Honestly, you can read how many articles you want and check LinkedIn posts, but you really need to experience it, because you need to make a certain click in your brain. SQL comes with a certain way of thinking and writing the code. So I think the best way is to create a free account in one of these players, or download MySQL. It's free. Download SQL Server Standard. It's also free. And just start building your own scripts with the help of ChatGPT to create exercises and so on.
Yeah.
So honestly, I don't think there are there are so many content. There are no excuses. I mean, anyone can learn SQL.
Yeah. Yeah. What I think about today is that, like you brought up like Snowflake and BigQuery, back when I was trying to learn more about SQL, you'd have to, like you said, you have to download MySQL or SQL Server. You'd have to like upload files. Every once in a while, a file would have some sort of issue because of this comma would be in the wrong place. It wouldn't be double quoted, something. So then you'd spend just some time setting things up. And nowadays you can just just sign up for Snowflake or BigQuery and like get access to their free data and start writing queries right away. So I think that there's something nice to that.
And Ben, another amazing thing that happened is if you go to Google and if you search SQL editor online, you will see like 10 or 15 websites that actually allow you to run SQL code against dummy databases they have behind, completely for free. You don't even need to configure anything. And they will give you tutorials on how to actually get to the solutions. So I think this became so massified. And that's why I think the community had a huge take on the growth of SQL, because all of these platforms and learning and educational tools popped up, and it's super cool to see this.
Yeah. Matthew just put a comment, so I'm just reading it. I just stopped watching the I guess it's Primogen's new video about AI making code illiterate. It's good to learn with AI, but the more I use it, the less certain syntax I become on my own. Yeah, I don't know if you watch. I think I watched this video recently too, where it's like when you use any of the LLMs to answer, and write code for you, it does become harder for you to be like, what do I have to write here again? I just want to tell something to write it. But,
that's honestly, I've faced that problem myself. There are lots of people that are saying, hey, now we can use ChatGPT to convert code from whatever SQL engine to another one. And then when you look at the code, it doesn't run. It has a lot of issues because honestly, these LLMs were trained with code that exists in the web, but not all the code is actually correct. So there's a lot of bad code out there. So we need to be careful. But at least for introductory stuff, I think ChatGPT works pretty well to generate exercises, like generate a data model for me to use in my dummy project in BigQuery and generate a SQL code. And it gives you the DDLs, so the creates and so on for working with that database.
Going forward, kind of thinking through use cases, like I'd love to kind of talk through what both of you have seen in terms of ways people are using SQL in terms of real life that people might not expect. And again, feel free for either of you if you want to start answering that.
Maybe I can go first, right? So at Snowflake, we're a big promoter of like using SQL for everything. So a big part is the SQL for ML, essentially machine learning. So what does it mean is that you can run all kinds of classic, non-classic kind of ML algorithms like train an XGBoost tree, right, via some SQL UDF, or train like a time series prediction model on and use it in SQL, or doing the sentiment analysis to classify, for example, customer service transcript, etc. And it's even becoming more prevalent nowadays because with a large language model. So Snowflake, for example, and Google BigQuery has this large language model functions, right, where without messing up with the Python code and messing up with your own infrastructure, you can just use their infrastructure directly within their data warehouse to transform millions rows of customer service data. If your data is stored in there, many people don't do that today because they only store numbers in the data warehouse. But you can actually store the text too, to transform those texts into insights with large language models. So and one of other personal experiences I can share is at Snowflake, we also use ourselves Snowflake as part of our internal observability. So our logs would be directly logging ETL into the Snowflake table, and we use that to trace down some bugs as well.
Nice.
That is pretty cool. I think, Richard, everything you said quite aligns with what I have been seeing. I think the fact that BigQuery, specifically with Google SQL, they have been enabling more and more LLM operators for SQL, their SQL version on BigQuery, is actually quite impressive because you have very strong use cases like anomaly detection, text summarization. All of this is already achievable in BigQuery. And all of this in SQL. I keep telling to data engineers that come to me and say, "Hey, Rui, I'm afraid of, I have this fear of missing out this trend of AI and machine learning and so on, because I only know SQL and I only know about pipelining." And I always say the same thing: if you know SQL, you know enough, because in BigQuery you can train machine learning models, deploy them, and apply them entirely in SQL. And this, for me, it's fascinating. From a guy that started 15 years ago using SQL only for analytics, for data warehousing, and so on. I think it's really, really surprising and impressive, to see where you can apply. And I think this is only the beginning, to be honest.
Yeah. To kind of counter that, though, like, what would you say are places you think SQL shouldn't be used, right? Because I think there's a lot of places that SQL and companies like Snowflake obviously want you to use SQL, but where do you think it shouldn't be used?
Richard, you want to start?
Yeah, that's a tricky one, actually. I think my angle would be all out AP versus all out TP, analytical versus transactional, right? If you it's more of like, or vice versa, right? If you want to use like Snowflake to support your real-time query, let's say update an order price, like for example, and the speed will be slow, right? It will take like maybe 2 seconds, right? Because it's not like point-wise lookup at the data level, at data plane level, right? But in this case, a Postgres probably will better fit your use case. But if you try to like dump your analytical queries on your Postgres, then your live user will complain because their real-time query will take a long time to run.
Yeah, I think this one is really tricky, Ben and Richard. And honestly, for a couple of years ago, when I started using SQL, there was a pattern in the industry that I think it's slightly changing. This might be a bit controversial. Some people might agree with what I'm saying, some might disagree. But 15 years ago, it was very common to see all the business rules of a certain information system being stored on the database. You would have these huge store procedures or huge functions where you have all your business logic in there, right? And gradually, with the three-layered model, when you're designing information systems, we started moving this into the middle layer to APIs and to specific backends, because sometimes it's actually easier to store these business rules in a language like Python or like Java or something like this. And I think if we generalize this problem, I think it's when people try to use SQL for procedural operations, like they have these loop functions, they have these while functions, and I don't think SQL is actually a very good fit for this. For a while it was, because people believed business rules had to stay close to the database, but right now I think it's just an abuse, and you should try and spin off that information into some other language, which will provide you better memory efficiency, storage efficiency, and maybe SQL is not for that. So you should keep your models there, raw, connect using Python, Java, or whatever to your database, and then write your business rules in a language like this. So this is probably my first advice when it comes to abusing SQL. The second one is, I think there are still a few use cases that need a little bit more improvements. Like maybe sometimes when we say using SQL for multimodal models, it's very exciting. I think it's the future, and probably we're going to talk more about this. But there are a few angles where we need to improve how SQL is designed and written before we get to a place where it actually works for everyone. Because again, SQL was designed for relational databases. So maybe not all operators are going to use. Maybe joins are not the best option. So I think there are a couple of things we still need to rethink before we can really state publicly, hey, SQL is there, and SQL is going to be the future of multimodal LLMs and model interactions and so on. So I would give these two angles, one more historical, one more futuristic.
Yeah. The stored procedure one brings me back, especially when you see or hear like while loops or cursors. Anytime you've got to use a cursor in SQL, you're like, and this is going to take a really long time. And it should have just been in a for loop in some script somewhere. But it's just, you're already in the database, and it's just, like you said, it's like, it just was easy because everything was there. But yeah, it was.
And you felt like a superhero. I remember when I had to write these cursors, logic, and so on. You felt like, wow, I'm doing something out of this world. Maybe you are, because it doesn't fit here, right? Maybe you should be doing this somewhere else. But it was an amazing feeling when you made them work. But they were hard, and it's not easy because it doesn't really fit there.
Yeah. Speaking of kind of like, again, things that we're seeing changing. Richard, you on the Snowflake team, you drove a lot of like the text to SQL kind of projects, and that's something that I think has been a forever thing that we've been trying to do. So I just love to kind of know, like, what did you learn from kind of trying to develop text to SQL at Snowflake?
Yeah, what I've learned. Well, that's a great question. I think honestly, like a lot of people are doing it today. A lot of companies are doing it, but we're kind of piloting like very early, as soon as ChatGPT came out. I think our company, like we're Snowflake, starting thinking and design and ends up like implementing it. So the one-line summary is actually a very challenging problem. We think about like, okay, ChatGPT can generate like a text to SQL. If you ask it, you can achieve it anywhere from ChatGPT to Cloud to Gemini. But in a real-time world, Ray can tell more about this. But I'm not sure if you guys have tried text to SQL chatbot or anything like that. The database, the data schema is nothing like what you're asking in ChatGPT. It's like maybe thousands, and it's a complex graph. If we put it in a data visualization with columns, dependencies, and join relationship, it's a complex graph. So simple methods won't scale because, for example, you don't know the most common frequent running business queries just by staring at the data schema. You don't quite know the join relations because large language model cannot do too great job of running through those complex topology, many data columns are like stale, but you don't know either. the name can be like very fussy, right? Probably there's no description either. So in real life, customer users will be disappointed if they see the wrong SQL get run like over and over again. So later on we have shifted into what I call how about let's think about if you use the semantic layer of in the customer's data space rather than just doing like a a blank coverage of all the data schema you have. Just focus on the critical business queries and give users a little bit of room to design what they want to feed it into the into this like into BI intelligence layer. So that went pretty well. The internal there's a coding for it, but I won't be saying that today. I can look at it online. Yeah, so that's my experience. Be careful about productionizing the text-to-SQL.
Yeah, no, I think that's a great way of kind of describing some of the problems in the sense that one, you're looking at, like you said, thousands of fields, sometimes thousands of tables. The relationships themselves are hard. You brought up semantic layer. I think that's another challenge, like just trying to get companies to have that. I was talking to another consultant the other day where they, it sounds nice on paper, but like then you try to go implement it, and for various reasons, right? Like if you try to get a company to implement a semantic layer and take 6 months or a year to do that, they're like, we just want reports. So it's definitely very, very hard, I imagine. Are there any other kind of gotchas you'd say in developing like text to SQL that most people would be like again, like if you're developing it, you probably like initially like, wow, it's working until you get to this point where you finally just hit this thing where it's like, it's not going to work because of how we designed it. Like, are there like some design decisions that like will be gotchas in the future?
I mean, when we design tested, the benchmark, Spider benchmark has on the paper it's like perfect, but when we launch on the production, even the most like basic customer have significant problems with running have accuracy problems when running. So a couple decisions, which is like first, try to use a semantic layer. If not, right, try to cut down the scope of what they're asking. Let the user drive some of the kind of preference labeling over the time. So let them just choose what are the common queries they have run in the past and use that to infer what should be answered from the chatbot. The chatbot have this context of, okay, I should pick this like top 10 instead of like just choosing from the entire history. Tag the metadata. Like this is a kind of a data organization. Let your data organization tag the metadata of the tables. Don't leave it like empty. So some of the suggestions we have.
Yeah, no, I think that makes sense. I think. Oh, were you saying something?
No, that's really interesting. I mean, I can't go as at the same level of detail that Richard went, so I'm gonna stay here on this level. So keep going, Ben.
No, I was just gonna say I think that makes sense. Like you referenced preferences. When I was testing out, I think Databricks Genie with Josue. I don't know if you guys have seen them post on LinkedIn. That was something I think you can do, is like you can tell what tables to use, which then kind of helps, obviously, like instead of having your a chatbot or LLM have to deal with thousands of tables, you can be like, hey, just these are the 10 tables I need to use. Or you can like build it for someone else in the same way. It's like, these are the 10 tables they're probably going to use. So don't try to hurt yourself looking for other things. So no, that makes sense. As we were preparing for this chat, we were talking a lot also about like structured data versus unstructured data and like what queries can do there and what people are trying to do there. So what are you both kind of seeing in this space?
Yeah, I mean, maybe I can go first, Richard. I mean, the platform that I've been exploring the most is actually BigQuery. And on BigQuery, I think they're focusing right now heavily on text. So allowing you to call LLMs and be able to summarize text, to be able to classify text, to extract some specific keywords and takeaways and so on. And I think it's working pretty well. But there's a new trend coming in. I think there's a lot of people actually now working with images and with videos and trying to create these multimodal databases where you will have a SQL interface to actually interact with all at once. Imagine what it would be if you could actually use a video of a certain campaign that you have run, a TV commercial that you have run in the past, combine it with business metrics like how many sales did I get during that specific TV commercial, and then be able to generate automatically using generative AI new commercials that try to maximize conversion rates for a specific audience or for a specific target of people. And I really see this as a little bit of the future, us being able to combine relational data with embeddings extracted from images and videos and so on, and then generate a lot of commercial content with a specific target function. And this is something you're already seeing in a certain way. And I believe Richard is also investing a little bit on it. So I don't know, Richard, if you want to share a bit of the work you're doing, but I think it's really, really impressive. I mean, the trend that's out there.
Yeah, I totally agree with you there. Like, I think the trend is like people are like, well, I think it's still early in data community days, but I see the leadership like Rui is already seeing the trend of a future where the boundary of media data, multimodal data is blending with the traditional like structured data, just simply because now we have magic tool, right? LLM, which is really good at, which is honestly not great at numbers, which is why SQL is the best partner here, but it's good at extracting the insights from unstructured data. Right? You cannot ask LM to calculate like 10 million rows of numbers and give you a 100% correct answer. That's what SQL does. So just want to share like a little bit about my experience. So we're solving the problems, especially for to evangelize SQL. I think I heard evangelizing this term from Rui when we first talked. And but what we do is, what if you crawl the websites, right, with SQL? If you have a table of URLs and you want to just dig insights from 10,000 URLs, like for example your competitors, and you can just use it with SQL. You don't even write any other code, and in Python code you don't need to worry about how does it crawl. The only thing you need to worry about is to configure your prompt, and the SQL query will just run, right? Another example is the documents, right? When documents are traditionally only belong to AWS Tesseract or typical like OCR methods, but now everybody knows like ChatGPT can read a document. So what if we combine this power of large vision model within the SQL and let SQL kind of extract the text from the documents and understand those documents as a whole. So yeah, it's another very classic use case in many industries, in finance, insurance, etc.
Yeah. No, I think I get excited when I talk to both of you, because I think you guys are actually, doing a lot of things where you're testing ideas and like you said, like where you're trying to figure out ways where you can combine it kind of with your traditional, like, okay, we have customer segmentation data. Based on that, we kind of can understand how they responded to this commercial. Based on that, like, what can we tell about this commercial that maybe makes it stand out, and then kind of query it and try to dig into it more to make another similar thing, whether it's to generate it via video, or probably more likely, I seem to maybe generate like ideas that are similar, or scripts or something that can then be better improved.
And to be honest, man, you can go wild. You can even have website generation. If you go to an hyper-personalization conversation where you have an e-commerce shop and you want to offer, a personalized experience to your customers, right? You can learn from the past experience, and you can have Gen AI generating, a whole website for you. And maybe SQL has a saying here. Maybe you can do something like, select all from a certain customer table and then call a specific function in SQL that will generate the website based on the experience of that client with you. I mean, you can really, really go wild, because if you think about it, we have a lot of things out there, mainly in our world, where creativity is involved. So maybe we can leverage some of this and combine it with our relational databases to boost our industry a little bit. And I think it's fascinating when you start dreaming about this.
It's streamlined. Yeah, it's honestly streamlined, right? If you can generate it, and you can generate like 10,000 of and honestly, right, we all know like generative AI hallucinates, and it will generate some like random photos. So you can probably generate 50 photos of an individual item, and then use the SQL to evaluate it against those like 50 generated pictures, and then pick like 3. That's how high quality. So you can kind of do this kind of a what do we call it, streamlined AI generation, AI validation, and then actually like pick the AI ranking all together within SQL on media.
And to be honest, I don't think we are that far from having that massified worldwide. Because if you think about it, vector databases and storing embeddings, it's becoming an active topic in any organization. You know, what's going to be the embedding size that you're going to use to store your images and your videos and your audio so that you can make it available for the whole organization. So I think that the storage of embeddings, it's already an active point of discussion in many companies. And you need to think this in coordination with your existing data storages. So again, multimodal data storages is not something of the future. It's actually there today if you want to really leverage this whole wave of Gen AI, LLMs, and RAG applications, and so on. So you need to start thinking about this right now as a unified concept.
Yeah. Yeah. As people are kind of trying to think about this, what would you say is different when it comes to like querying, in particular, like unstructured data? Like, can we aggregate? Like, how do you treat aggregates? How do you kind of run all these other things that maybe are kind of different when you think about them, like mentally?
Yeah, and to Rich's point, right? In like 20 years ago, it's like SQL is not born with the functions that we see today, like window functions, right? And SQL today like don't have a syntax for example, for you can like do in a where clause where an image just like a horse, for example. I'm not doing something like this simple, but I think embedding, as Rui said, will be commoditized. It will be baked into any commercial data warehouse. I hope, right, in the next like 2 to 3 years. So we're gonna change the like query to make it support for image. But now there's also another challenge: is how does it work for like even more deeper like data, like documents, right? How do you do a like for documents? Do you like find the results per page, or do you find the relevant documents? How do you do it inside the video, right? Versus just a broader like what's the video's theme is about. So we have to. There's more research efforts, I would say, and more customer use case needs to be going to here. And aggregation, right? Today you can just feed multiple images in a same context, right? So same thing. How can you like move those binary bytes from different rows into one aggregation function within the SQL? So that's another point. I'll have to Ray for just in case you have not some thoughts.
Yeah, I mean, you covered some of it. I really think that when we look at the foundations of SQL, we need to rethink how the joins are going to work between relational data and images and videos. How are we going to relate the embeddings and so on? The other day, I was using my phone, and of course, iOS and Android allow you to actually search images by a specific keyword. You can write cars, and it will give you the images there. And I dream about the world where eventually I can write a SQL query like this: select all, which is all the metadata from images table, grouped by car. And car doesn't really exist as a column. Car is actually inferred from all the images that I'm storing. And I can actually group by all of my images simply by calling the group by clause. And the engine must actually decide what are the images that are going to be included in each of the group sets. And this is something that doesn't really exist, right? And I think we need to start thinking about this. How can we build an engine that will support all these amazing operations that we can enable in a multimodal storage architecture?
Yeah, I think that's definitely something I haven't thought of. It's an interesting idea, like trying to think of like a where clause or a like clause where it's like where it's a horse or where it's like a horse, and then just give me everything of that. Or same thing with like, same thing with like movies. Like, hey, give me everything from like, give me all the clips from the movies that we have that have horses in them and like the time stamp of them, and then you can like aggregate how often a horse shows up on your clips that you have stored in your video file somewhere. I imagine that gets really, really complex.
That's actually quite cool, because now you made me dream a little bit, man. Imagine that you write a query that says select actor, and then you put sum of airtime from movies, and movies is just a set of videos. There's literally no structured data about the video, and the engine actually infers in how many frames a certain actor appears by using visual similarity, for example, and then you group by actor, and you get exactly how much time that actor actually showed on TV, for example, just by running a simple query on top of a video. And I think these use cases will be amazing whenever they're possible.
Yeah. It feels far away. Go ahead. Sorry, Richard. I think you're going to say something. Go ahead.
I'll give you something because it's quite interesting because I know that deep learning and Andrew Ng, probably you guys know him. He has a couple of videos actually showing some of this that I've just described, and it's literally impressive. You can put a video of a football match, and you can count how many players you have on an image and so on. The only problem is he doesn't use SQL, so he needs to fix that specific part.
Richard, were you going to say something?
Yeah, no, I was just gonna say like one of the we're kind of building some of the vision, risk vision into our data platform. But so one of the the biggest difference between like at the bare metal layer when we do the list level of compute, transforming tens of thousands of videos into some kind of insights, is the memory footprint. Just some kind of behind the scene, because traditionally when we deal with numbers, right, you can think like, behind the scene, right, each node will at most 50 gigabytes, right? Let's say, and you can fit in a lot of data in one node. But then today, one video maybe just exceed like 50 gigabytes. So how do you stream that data? How do you prevent your memory from explosion? Especially nowadays, like everything is multimodal. It's quite an art. So that's needs a lot of engineering efforts to put in. Honestly, like everything we have mentioned here is technically doable with a set of Python queries and with a bunch of servers.
Yes.
But how to make it simple again? That's the main theme.
Yeah. Because like even as it was brought up earlier with like the Apple example with like your photos, it's at least my guess is it's a bunch of metadata that's being stored somewhere in the back end, or that's how the natural approach has been for a long time, where it's like, all right, first we will run a Python script over these videos or these images, and then we'll store a bunch of metadata for what actors in it, what's in the picture, how many soccer players are there in each in each frame, etc. And we'll store that somewhere, and then you can write a query against it. Has definitely been more of the approach. But like you said, that requires Python, that requires more time. It's expensive. It's unavoidably expensive in either direction, where it's like you have to run it on some sort of compute. And so, that part is, I imagine that will stay for a little bit until we can get the like LLM vision approach to work in a way that makes sense. But Richard, you're solving that problem, so I'm not worried.
And I can even share with you guys that one of the known problems about SQL is actually extensibility, because every time you introduce a new operator or function or whatever, there's the big risk that you're going to break the syntax for previous scripts that you have. But the good news is that we have some companies, and Google is leading on that front. They are rethinking SQL, and they are rethinking how can SQL become extensible in the future so that you can actually introduce more and more operators over time. And they're calling it pipe SQL. Instead of writing SQL as a script, as a query, you can actually pipe operations, and you can literally build a new operator and put it in the middle without breaking anything from the past. So I really encourage everyone listening to really Google about this. It's quite cool how they are envisioning the SQL of the future.
No. Oh, were you gonna say something, Richard? Sorry.
No, it's just quite cool.
Yeah, no, it'll be interesting to see. The last time, I like to poke at this, the last time Google tried to make a new SQL, they did not do well. And now they call it legacy SQL, which always is like, but you're not the legacy SQL, ANSI SQL is the legacy. But that's just always something funny.
Yeah, I mean, people love the old SQL. It's here to stay.
I don't know. Do either of you have any other thoughts in terms of like where SQL is going in the future?
I mean, I really think this is one of the steps. I think we need to rethink SQL, because again, SQL has a lot of known issues. The fact that it's not extensible, it's one of them. The other one is that SQL forces you to think inside out, even if you don't want that, right? The fact that you need to nest queries, or even with common table expressions, you always need to start with the most granular query that you want, and then build it until you get to where you want to be, right? So it really forces you to think inside out. And sometimes we have problems that are not really like this, right? You start with something and you want to enrich that something over time. Like you start with an image, you add metadata, you add relational data, and so on. So SQL has a lot of problems, and someone needs to crack it. But I think right now we are in a confused world where, and I think Richard, you mentioned this a couple of minutes ago. It's really confusing right now. Even Google, if you try to use their anomaly detection functions, you will see that they kind of patched the functions into the syntax of SQL because it's not natural, right? It's not very easy to extend that capability. And so I think we need to make it simple again. Now I'm stealing the words from you, Richard. We need to think about multimodal storage, but actually think how to make SQL simple again to accommodate all of these changes.
Yeah. Do you think maybe it comes a little bit down to like the how the data is stored, or is it SQL? Because I think that's always something interesting, right? When I tell most people, I'm like, look, SQL is easy to learn from a syntax standpoint. The challenge is generally the data, right? Like understanding the data, how it works, how it operates, how it joins, and how what you're doing impacts it, right? Like, okay, when you write a select query, and if you have a join, and there's the same ID on both, and there's multiple, of both IDs or the same ID on both tables, you're going to have it, have some sort of like not a Cartesian product, but it's going to explode, essentially. So, like, is it partially how the data is stored? Like, where do you think the fix might be?
Richard, I don't know if you want to take this one.
Yeah, I think if I were to say what's most important, I mean, to the commercial providers, right? Definitely there's a lot of engineering work is happening on infrastructure and data store, like how to store data efficiently. But I think to the user, it's still like the syntax, right? You can essentially jam like everything, jam UDF into SQL and make it, but people won't use it if it's not like easy. So I think just how to design like a genius way to prompt engineering, right? Stuff like this is gonna be most, and honestly, like you cannot even see the multiple data within the SQL warehouse interface today. So that's just a little step, but just proof to say I have to be very thoughtful about your user interface as a whole.
Yeah, makes sense. Yeah, cool. I like that. It is really kind of thinking about the user, because like we referenced earlier, it really has been the user that has made it explode so much, in the sense that it's easy to use. A lot of people can access it, so that is why it's very popular.
Yeah, and if you look at the history, and sorry guys, I'm the old man here. I'm always pushing you guys back into the past, but we see signals of this happening, Richard. For example, in the big data world, we had these very complex map-reduced jobs. Not sure if you guys remember this. And then SQL came to simplify or to build this abstraction. And you would write Spark SQL, and then it would get automatically translated into MapReduce or Spark in this case. So we see that happening more and more often recently. So I fully agree with you, Richard. I think it's really about simplifying the interface, but also simplifying the engine that's behind. Because at the end, we want to abstract the complexity away from the end user. We don't want it to be the one fixing it. And that has been the magic of SQL over time.
Yeah. I like that. Awesome. Well, I'm looking to see if there's any questions. If anyone does want to ask anything, feel free. It was a good chat, I think, but I'll kind of leave it up to you guys if you have any thoughts that you'd like to leave with, but I'll also wait to see if there's any questions.
Yeah, maybe I can share something. It's a question that I had a lot when people knew that I was coming to speak to you guys. I've heard this a lot. I mean, people saying, hey, is SQL actually going to disappear with Gen AI, and now that I can literally write? And we kind of talked about this. And I think there is one very interesting aspect about SQL, in my perspective, is that SQL is kind of deterministic, right? So you know what clauses you need to respect. So you know what output you can actually expect. When you write in natural language, a slight variation on how you write the prompt or how you actually write your sentence can actually cause a huge difference in the SQL that's generated or in the data that you're getting. And so I think SQL will still be very interesting, even in this modern world, because it gives you the determinism that you need to actually trust and rely on the queries that you're running against a specific storage. Maybe I can also ask your opinion, guys, but this is a sentence or a question that I'm hearing a lot. Like, what do you think?
Yeah, and maybe and I think to your point, like many people think data analyst will disappear because now machine can write SQL. I think it's a valid concern. I mean, right, because if all the BI AI will keep iterating, right? We've seen the new models coming on like every day, and they're just getting smarter and smarter. And sometimes some days they might be able to teach themselves. Who knows? We're not far from that true like AGI or ASI. But I think. Well, with that being said, right, structured data is definitely it has a risk of being it's too much, like it's too mature, right? If you think about it, if it's too mature, and we do have to think about, okay, what's a data analyst gonna do? Where are they gonna be at, right? When structured data query is no longer a problem. That's where I think the unstructured data is gonna be a big blue ocean for everyone. We talked about this a few minutes ago. You can generate media assets with SQL, right? Data analysts haven't done this before, right? This is just operational task. This is like serving direct to the marketing business functions within your company. It's not analytics. So, but you can think about it. You can start doing it, right? Analyzing the documents, right? Analyzing your competitors' websites. Those are typically engineering work, right? But now data analysts can do it because you have this magic wand that allows you just to tap into anything and do it by natural language with SQL really fast. You're probably doing it even faster than your engineers if you're a good SQL user. So I think there's a ton of possibility that data community can just tap into that I'm super like excited about to see what's happening in the terms of the position wise in the company.
Yeah. No, I think that's an exciting kind of space, especially with what you're doing, Richard. Overall, like what I've seen, I think in terms of like, I like that you brought up like deterministic, Rui, because I think that's the big thing is like, even now there are certain things I've asked different LLMs and testing out ideas like, hey, can you count something, or can you do something that would seem like a basic task and it'll give you a different result every time. You're like, can't you give me the exact same result? I'm just going to write my own script to do it. Or I'm going to ask you to write a script to do the thing that I'm trying to actually do. And the same thing I think kind of goes on the SQL side, where it's like you brought up earlier, like if you just ask it in a slightly different way, it gives you a slightly different answer. I always use the example, and it's going to get old eventually, but I always use the example of when I did that chat with Josue with Databricks Genie, and we were asking it a certain problem or a certain question, and it didn't write the query perfectly, but there's no way a non-technical user would know that. But Josue was able to go in there and look at the query and be like, oh, I'm going to re-ask it a different way to get the query I want. And it's like, well, you're kind of still aware of, you're aware of the data, you're aware of how the query works, and that's why you can do that. But if you're not aware of how the data is set up, if you're not aware of how queries work, you're going to have a hard time doing that. But it definitely, like in terms of like speeding up the process for analysts and speeding up the process for data engineers, that's something I continue to see. But I'm still opening up 1,000-line queries. So until I stop seeing 1,000-line queries that I don't know if current ChatGPT or whatever model you're using can like fully process and get what's going on, I don't know if we're going to see those get replaced anytime soon. But I think it's interesting kind of trying to see where those will all fit in the future.
Yeah. And I have an analyst friend that says, well, while my stakeholders keep making this nonsense requests, I'm safe because they don't know what they need. So I think that's probably a role that will take a while to replace, to be this translator in a way.
Yeah. It's a good way of putting it. It's like maybe that'll be the new role someday. I don't know. Who knows what it'll look like in 10 years. I think that's the hardest thing is like for the next 2 to 3 years, I think things will stay about the same. You'll add a little more. In 10 years, it's going to be a different world, and I don't know what it's going to look like, and no one does. So,
That's true. Maybe one day we'll talk to databases, and it will be super accurate and sharp. But
it could be, someone's out there trying to solve that problem, and that's the thing. It's like I think one of the issues is it's easy to point at the problems that we're running into today. Be like, well, this will never work. We're running into these problems. But if you're saying that, there's someone else somewhere else that's trying to solve it, trying to be like, yeah, that's a problem, and I'm working on how to solve it. That's why I imagine, Richard, you were doing at Snowflake, trying to solve like, okay, we have these text-to-SQL issues. Okay, here's problem number one. How do we solve this? Okay, we keep, our clients keep having this, but it's good about that iteration. That's why I do imagine it'll be something like a Snowflake or a Databricks or some company of that nature that will really solve, hopefully, that text-to-SQL issue if it is solved, because they have all the iteration speed when it comes down to it. So cool.
Yeah, and maybe one last message from my end, Ben, which is, of course, we are here evangelizing SQL because I personally believe SQL has a big role to play, mainly in helping people, get into the Gen AI world, because most people started in the business intelligence world. This is how most of us were called, BI developers a couple of years ago, and many data engineers only know SQL. And when I say, if you know SQL, you know enough. For me, it's enough to transition. Like, if you know SQL, try to create a BigQuery account, try to use their SQL clauses to test out calling LLMs and so on. Start training models. So it's a good vehicle, I would say, to jump into this new world. But at the end, don't abuse SQL, right? Because there are use cases where it just doesn't make sense. If it's very procedural, if it requires a lot of logic, a lot of algorithms, maybe SQL is not the best friend for you. Maybe you need to look at something else. So again, SQL has a vehicle to the modern world, but then try to diversify and learn other stuff as well.
Yeah. If you're going down the route with cursors or while loops in SQL, you're going down the wrong you're probably going down the wrong road. That's what I learned. I think I wrote that in an article back in like 2018 or 2019. It was like, it worked. What I learned was don't do it.
Yeah.
But more than likely, it's a don't do it. It has its places still, but yeah, awesome.
It's
cool.
true.
Well,
many companies still use it. Sorry, Ben.
Yeah. No, I was just gonna say thank you both. If I don't know if you have any other final thoughts, but if not, I appreciate this. It was a good chat. We had a lot of people watching on both LinkedIn and YouTube, so I appreciate it.
Yeah.
Thanks for having us.
Thank you.
Thank you.
Thanks for having us.
Awesome.
Thank you.
All right, I'll hit end stream.